So from now we can say that we know the power, how much power of the synchronous machine is there. So we know power is equals to EF into Vt upon xs into sine delta plus of V square by 2 into 1 minus xd x cube sine 2 delta. There is a thing which is called as the electromagnetic power. This is called the electromagnetic power. And this is called the reluctance power. So one thing which is very important now is that we have seen the synchronous power and we have seen the electromagnetic power. There is a slight difference in that. Here it is sine delta, and in the synchronous power we have seen that it was cos delta. So please remember this thing. When the electromagnetic power is concerned, sine delta will be coming here, and when the synchronous power will be concerned, at that time cos delta will come, and because of that cos delta, cos 0 is 1 and cos 90 is 0, and sine 0 is 0 and sine 90 is 1. So from that one can understand when the electromagnetic power increases, the synchronizing power decreases, or the synchronized power increases, the electromagnetic power decreases. So that is a very important point now. So we can have the electromagnetic torque, maximum electromagnetic torque or the power by differentiating this with respect to delta and putting it to 0. So we can have maximum condition for power in case of electromagnetic power is that such that the delta is equals to 90 degree. So if delta is equals to 90 degree, we will get the maximum power, electromagnetic power. But when the delta is 90 degree, we will get 0 synchronizing power. So it is very important for objective type of questions that when delta is equals to 0, the electromagnetic power is, when the delta is 90 degree, the electromagnetic power is maximum and the synchronizing power is 0. And at the point the 45 degrees, or the delta is equals to 45 degrees, the electromagnetic power and the synchronizing power both are equal. One more important thing comes into synchronous machine is called a short circuit ratio. It is also called as the SCR. It is defined as the field current at rated voltage at open circuit divided by the field current at rated voltage at short circuit. So IF upon the field current at rated voltage at the short circuit. This is called as the short circuit ratio, SCR. This, the field current at rated voltage at the open circuit to the field current at rated voltage at the short circuit is also equals to the 1 by XT, which is an important relationship. Please remember this relationship for objective type of question. This is very important, and we'll see what are the values of the short circuit for non-silent pole, and for the silent pole we can have that. Then for non-silent pole the short circuit ratio must be between 1 and 1.5, and for this, silent pole type it is 0.5 to 0.7. So for non-silent type of rotor, SCR is normally between 1 to 1.5, and for silent type this ratio is 0.5 to 0.7. What is the use of the short circuit ratio? First of all, we can have different things, and we can understand this thing, that what is the use of the short circuit ratio. As we have said that the short circuit ratio here, the short circuit ratio is equals to 1 by XT. So in case of the voltage regulation, when we talk about the voltage regulation, since if the SCR is low, but obviously the XD would be high, and if the XD would be high, then the voltage regulation will be poorer. So the SCR should be high to have the higher voltage regulation. Second thing comes for the paralleling operation. When the SCR is low, the XD is high, then the so when it comes to parallel operation of generators, and if the short circuit ratio is low, it means the XD is again high, and at that point it will be difficult to synchronize that to the paralleling, in either to the bus or either to the generator. So paralleling operation is difficult when the short circuit ratio is lesser. So the short circuit ratio should be as high as possible. When it comes to short circuit current, a low SCR is resultant high XD. So it means that the low short circuit current would be there. So the fourth thing will be for the self-excitation. If the alternator is fitting to the long transmission line, and it should not be designed with small short circuit ratio, as that would lead to the large terminal voltage, and on open circuit due to large capacitive currents. That is also important. So one thing also comes that when the XD is high, the efficiency of the machine will go down, as we have seen. This will be giving some losses, and at that point the losses will be deteriorating the efficiency. So the SCR should be high as possible. This is an important thing. The SCR should be high as high it could be, and for we have seen that for non-silent pole it is between 1 and 1.5, and for silent pole it is 0.5 to 0.7. So when it comes to parallel operations of two generators, then the SCR should be as high as possible. And this is very important relationship. SCR is equals to this IF by IF on open circuit and short circuit at rated voltage, which should be equals to, which is normally equals to 1 by XD. So this is very important relationship, and on this few questions can be asked in objective type of question, objective type of examinations. So one more thing comes after that is called a slip test. It's called the slip test. In the slip test, we normally found the XD and XQ. In the slip test, as I said, we'll be finding the XD and XQ, and we know that an XD and XQ will be different for the non-silent type of machine, which is also called as the, we have seen that dumbbell type of rotor, that is also called as the dumbbell rotor, that is non-silent pole. So this test is normally for sorry, it's not for non-silent pole, it's for silent pole machine only. So I can write it's for not for non-silent pole machine. It means that it's for silent pole machine. So the thing which we'll be finding will be the XD and XQ, and this relationship will be given. So it is how this test is conducted. First of all, the test is conducted to find the XD, XQ and the armature resistance if it is required, and the alternator is energized with the field unexcited, and we measure the line voltages, and from the formula XD XQ we find the XD and XQ. We can say that XD is equals to V maximum to 100 to 3 I minimum, and for XQ V minimum divided by 103 I maximum. So we will give the XQ. So by this we can find the XD and XQ, and these two relationships are very important in objective type of questions again. XD is equals to V max by under root of 3 I min, and XQ is equals to V min divided by under root of 3 I maximum. So this relationship also is important for objective type of question. Please remember this formula also.